Dyson Swarms Star-sized supercomputers. Welcome to NDJWonders, a channel under NDJProductions. Today, we're exploring an idea so vast that it turns an entire star into a machine, not a weapon, not a spaceship, but a tool. A structure so ambitious that it blurs the line between engineering and astronomy and makes science fiction feel almost modest by comparison. The story begins with a simple question. If a civilization keeps growing, where does it get its energy? On Earth, our progress has always been tied to how much power we can harness: fire, steam, electricity, nuclear reactions. Each leap forward unlocked new possibilities and reshaped society. But as energy use grows, planets impose limits. There's only so much sunlight, land, and fuel to go around. To move beyond those limits, a civilization would have to look upward. In 1960, physicist Freeman Dyson proposed a radical idea. An advanced civilization might surround its star with structures designed to capture as much energy as possible, not just a little more than a planet receives. Almost all of it, the output of an entire star, redirected for intelligent use. This concept became known as a Dyson sphere. But despite the name, Dyson never imagined a solid shell. That would be unstable and impractical. Instead, he envisioned something far more realistic and far more unsettling. A swarm. A Dyson swarm would consist of countless satellites, habitats, and collectors orbiting a star in coordinated paths. Each piece captures a fraction of the star's energy. Together, they form a glittering cloud of machinery, slowly drinking in stellar power. To understand the scale, consider the sun produces more energy every second than humanity has used in its entire history. Capturing even a tiny percentage would dwarf all planetary power sources combined. Capturing most of it would place a civilization closer to godlike than human. But there's more to this idea than energy. Once a civilization controls star-level power, new possibilities emerge. Massive computation, artificial worlds, simulated realities, and eventually, something even stranger: star-sized brains. This is where the concept of the Matryoshka brain enters the picture. Named after Russian nesting dolls, a Matryoshka brain is a layered system of computational shells built around a star. Each layer absorbs waste heat from the one inside it, using that energy to perform calculations. The closer to the star, the hotter and faster the computation. The farther out, the cooler and slower. The result is a machine that uses nearly every photon emitted by a star to think. Not metaphorically. Literally, such a structure could simulate entire civilizations, reconstruct extinct species, model universes with different physical laws. It could predict futures, analyze histories, and store minds in digital form. At that scale, intelligence becomes an astronomical phenomenon. But this isn't just science fiction. Physics allows it. The materials required don't violate known laws. The energy flows. Makes sense. The thermodynamics check out. The biggest obstacles are engineering and time. Building a Dyson swarm would take centuries, perhaps thousands of years, even for an advanced civilization. But it's not impossible. And this leads to a chilling implication. If such structures are possible, and if intelligent life is common, then some stars should already show signs of them. Dyson himself suggested that we could search for infrared excess around stars. A star wrapped in collectors would appear dimmer in visible light, but brighter in infrared, glowing with waste heat. In other words, it would look wrong. Astronomers have searched. In 2015, one star in particular captured global attention. KIC 8.462.852, also known as Tabby's star. It showed irregular, massive drops in brightness, unlike anything seen before. Some dips blocked over 20% of the star's light, far more than any planet could explain. Speculation exploded. Could this be a partial Dyson swarm under construction? Further observations eventually pointed to dust and debris as more likely explanations. But the fact that the idea was even plausible speaks volumes. The search for alien megastructures is now a legitimate field of scientific inquiry. To understand this better, think about how we might appear to distant observers. Earth is already changing its planet's signature. Our atmosphere contains industrial gases. Our night side glows with artificial light. Given enough time, our energy use will leave detectable fingerprints. A Dyson swarm would be the loudest fingerprint imaginable. What happens afterward is even stranger. A civilization that builds a Matryoshka brain may no longer care about physical expansion. Instead of spreading across the galaxy, it might turn inward, exploring simulated worlds richer and more complex than reality, running trillions of conscious minds at once. From the outside, such a civilization might appear silent. No radio signals, just a star wrapped in quiet, efficient machinery. This idea offers one possible answer to the Fermi paradox, the question of why we don't see extraterrestrial civilizations despite the vastness of the universe. Perhaps advanced societies don't colonize aggressively. Perhaps they retreat into computation, hiding in plain sight. But there's a darker side. Building a Dyson swarm requires dismantling planets. Mercury is often cited as a likely source of raw material in our own solar system. Entire worlds reduced to components, asteroids harvested, moons stripped, the architecture of a star system rewritten completely. In doing so, a civilization makes an irreversible choice. There's no going back to a natural sky, and once such a system exists, it becomes vulnerable. A failure in orbital coordination could trigger cascading collisions. A deliberate attack could disrupt energy flow. At that scale, mistakes are catastrophic. There's also the philosophical cost. If minds can live forever in simulated perfection, does physical reality still matter? Does exploration lose its meaning? Does risk vanish? Or does stagnation set in? Some researchers suggest that civilizations might deliberately avoid building Dyson swarms for this reason, that the temptation to retreat into artificial infinity could end progress altogether. Others argue the opposite, that such structures are the natural outcome of intelligence maximizing efficiency, that not building them would be irrational. Right now, humanity stands at the very beginning of this path. Our satellites are primitive collectors. Our data centers are crude. We are learning how to coordinate machines, manage orbits, and turn energy into information. Step by step, the direction is clear. The Dyson swarm is not a fantasy of distant aliens. It is a mirror held up to our own future, a possible destiny written in physics, waiting for technology to catch up. Whether we choose that path remains unknown, but somewhere in the galaxy, around some quiet star, there may already be a structure older than our species. A machine the size of an orbit. A mind powered by fusion light. Thinking thoughts too vast for us to imagine. If you enjoyed this video, visit the links below for more content from NDJ Productions and NDJWonders.